This video will cover the basic steps for visualizing multispectral data from MicaSense using the free and open source software QGIS. The RedEdge MX offers a 5-band solution for advanced agricultural monitoring and remote sensing analytics. The Altum integrates a radiometric thermal camera with 5 high-resolution narrow bands capable of providing advanced thermal, multispectral, and high-resolution imagery in one flight. The RedEdge MX dual camera system integrates 2 5-band cameras for the most advanced remote sensing and vegetation research applications. The 10 high-resolution narrow wavebands enable advanced analytics and offer a similar coverage to Landsat and Sentinel data products at a much higher spatial resolution. Load QGIS and start a new map document. Then click on the Open Data Source Manager. Navigate through your file structure to your multispectral data. Double-click on the raster of interest and it will add it to the map document. Once our raster is loaded, we need to ensure that the correct bands are being loaded by QGIS for our multispectral data. Double-click on the raster, go to the Symbology tab, and ensure that the red, green, and blue band are set appropriately. For a MicaSense RedEdge and Altum sensor, the red band should be in band 3, the green band at band 2, and the blue band, band 1. We can now see that the correct colors have been loaded into the appropriate bands. To create a false color composite, let's go back to our band rendering stage and change the band order so that our red band is band 4, which is our infrared data. Our green band will be set to band 3, which is our red channel, and our blue band will be set to band 2, which is our green channel. If you would like to create a single band visualization of the RedEdge or infrared channel, double-click on the raster, set the render type to single band gray or single band pseudo color, check the band of interest, in this case near infrared, apply any interpolation, color schemes, or classifications that you are interested in, and apply. If you would like to create an index such as NDVI, we can go to the raster toolbar and select the raster calculator. Here we can add an expression or equation, which will be our near infrared band minus our red band divided by our near infrared plus our red band. We can then check that the expression is valid and set an output name and ensure that the output format is set to the appropriate one. Once the operation is completed, you should then have an NDVI layer which is automatically added to the map document. It should range from -1 to 1. QGIS offers support for multiple map views, which can allow us to view each of our data layers concurrently. To do this, we can go to the View toolbar and select New Map View. Take the new window, toggle it to the side of the screen, and you'll see that the data is replicated in both windows. To see different data in each map view, we need to click on the Manage Map Themes icon, which looks like an eye. Click Add Theme, and we will add an NDVI theme. Select OK. We will then click off the NDVI layer on the checkbox, showing our RGB layer below. We will click Manage Map Themes again and add a new theme called RGB. We will then select in each map window the appropriate theme. So in our Map 1 view, I will select NDVI. As you can see, you now have both windows showing the same area, but with different data showing. There are a few key settings we can change to ensure a better viewing experience across all of our map views. Select the View Settings box, ensure Synchronize View Center is selected, and click on the Synchronize Scale checkbox. What this allows us to do is pan across one map and have the subsequent movement changes occur across all of our other map windows, like so. If we would like to make another map view using the false color composite band ordering, we can right-click on our original dataset and duplicate the layer. The next stage is to double-click on our copied layer, go to the Symbology tab and change our band ordering so that near infrared is in our red band, red is within our green, and green is within our blue to create a false color composite. As before, we need to create a new map theme for our false color composite. To do that, we tick the box off on our RGB layer, tick the box on for our false composite, select the Manage Map Themes, which is the eye icon, click Add Theme, give it a name, select OK. Now let's reset our original map view to RGB, like so. And as we did before, go to View, New Map View, and dock the new map view below our Map 1. Then click on the Set Theme button and select False Color Composite. We now need to synchronize all of our map views together. To do this, as before, we select our View Settings option and ensure that Synchronize View Center is activated, as is Synchronize Scale. We should also check that the scale factor is consistent across all map views. In this case it is. We can now move in our main map view, and each corresponding movement is recorded in each of our other views. Depending on the resolution of your data and the specs of your machine, there may be a slight delay in the redrawing rates for your windows. It is also a good idea to keep track of the various layers you have created. In this case, we know that our bottom duplicate layer is actually a false color composite, so just rename that accordingly to keep track of each of your layers.